Can you hear me online there? Yes, I see a yes. Great. And I am recording this on Zoom. So we're going to share out the recording afterwards. But welcome to the first ever Lightning Talk series put on by the Colorado Water Center. So the purpose of these talks is really to just bring faculty and staff and extension, folks who are doing work on the ground together to talk about the different work they're doing in water. And so a lot of times on campus, we get a little disjointed, we get in our silos and there's not a lot of sharing that goes around. So really trying to bring people together and form some potential interdisciplinary teams and connections that way. So that's why we're here. I'm Karen Schlatter. I'm the interim director of the Colorado Water Center and host of your Lightning Talk series. So for those who are not aware of the Colorado Water Center, we are here at CSU. We promote interdisciplinary research, education, and engagement to address our complex water challenges across the state. And we're organized under the Office of Engagement and Extension. We are also one of the 54 water resources research institutes, which again gives us our statewide mission. Hey, Debbie. And we work with a lot of different folks across the state. So we're really kind of that connecting organization between CSU and other academic organizations doing research and our communities, our stakeholders in water. And I will just make a short plug for various RFPs that we have out right now, and hopefully a lot of faculty will see this and students. So our first one is our kind of internal grants program, our water center program. That's for CSU faculty only, faculty, extension, research, staff, whatever category you fit in. And all of this information is up on our website, so you can find the RFP information there. The second one is for the CWCB Water Resource Search Seed Grant Programs. That's for any Colorado institution in the state. So it's a little bit more competition, but those are up to $50,000, I believe, per project. And then we have our 104B graduate student research grants. Those are specifically focused for grad student research. I think they're $10,000, up to $10,000 each. And that's funded through the USGS. So again, look on our social media, look on our website, you'll find all the information there. Most of these are due at the end of March. So yes, we are starting our Lightning Talk series. This is so far for our spring semester of this year. I would say, depending on how much people like this or how much interest there is, we might extend that and at least, continue these kind of collaboration type events where we're bringing folks together to share their work. And so I'm going to share kind of a sneak peek at our next Lightning Talk series. Session 2 is going to be based on water quality research and engagement, and that's scheduled for March 31st, 10 to 1:15. Probably similarly, we'll have it here with remote participation options. And so we've got a great group of folks for that day as well. We'll get our third session scheduled for April, and I'll send out the word on that. So that brings me to today's speakers, and I will just make sure everyone is okay on the chat. Yes, okay. So we're going to go ahead and get started. How this is going to be set up. So each speaker has about a 7-minute talk. We'll take 1 to 2 questions afterwards from our audience, and then we'll leave enough time at the end to have 15-20 minutes for discussion with the group. And that can include, interdisciplinary questions, etc. And yeah, I think that's all the logistics. I'm going to try and keep these folks on time so we have enough time for questions. So our list of speakers here, we've got Tammy Albrecht, who's an assistant professor of watershed sustainability in the Department of Ecosystem Science and Sustainability. Stephen Conrad, who's Associate Professor of Systems Engineering in the Department of Civil and Environmental Engineering. Francis Davenport, who is an Assistant Professor of the Department of Civil and Environmental Engineering. And Jacob Peterson Perlman, who is an Assistant Professor in the Department of Anthropology and Geography. So as you can see, this is a fairly diverse and interdisciplinary group. And I'm going to pull up our next set of slides here so we can go ahead and start with that, which we are doing Francis first. Is this the first?
That's my first time. Yeah, I didn't want to waste any time on a title slide.
Thank you, Francis.
Yeah, are you going to give me like a time warning?
I'll give you a warning. Yes.
Okay. So yeah, I'm Francis Davenport, and I will just preface this by saying that I'm partially trained as an engineer, part atmospheric science, part hydrologist. So I work on very broad things, and I'm going to try to give you an overview, but also a couple examples of more specific projects that we're working on. So very generally, my research group studies climate hazards, so especially extreme weather events, which we'll talk about, as well as climate impacts. So part of this is understanding how climate change affects things like floods, drought, and water resources. My background is especially focused on extreme precipitation and flooding, but a lot of the methods that we use extend these other events. So this is more traditional like earth science, atmospheric science, hydrology research, but how are these types of events that matter for people changing? And we also try to link those changes to impact. So for example, if extreme precipitation is getting worse, can we quantify what that actually means for people or infrastructure and that sort of stuff? And then lastly, we're doing some work to see how we can predict these types of events better. I'm not really going to have time to talk about that today, but I'm happy to answer questions or discuss. So within this area of understanding hydroclimate change, one of the topics we've been looking at is how the effects of a warmer temperature and shifting from winter snow to winter rain, how that affects hydrology and particularly floods. So there's been kind of this question of with less winter snow, do we get smaller snowmelt floods? Do we get more winter rain floods? And sort of what is this trade-off? Oh, the one thing I meant to, these icons were supposed to remind me to emphasize that we use a bunch of like large scale existing observational data sets. We use statistics and data science. So I'm not going out to collect anything. I'm a computational computer person. So to look at this question, we look at historical data for 400 different USGS stream gauges across the Western US. And some of the things we find using our different statistical modeling is that increases in rain-driven floods are going to more than offset decreases in snowmelt floods. So even without changes in precipitation, we expect increases in flood risk, although there's a lot of heterogeneity here based on region and climate. So this is a pretty impactful change, I think, in terms of existing infrastructure and sizing infrastructure in the future, and something that we need to be cognizant about is how these events are changing. So I have a student continuing this work right now. So it's not just the shift from snow to rain that we're interested in, but how does that combine with more intense precipitation events, combined with lower soil moisture from hotter temperatures and more evaporative demand? How do all these things intersect to affect something like flooding or water availability? So Mike Talbot, who's a PhD student in my group, is exploring this. We're using long short-term memory neural networks, which are a type of neural network often used in hydrology. So he's training these to predict stream flow. And this is takes a bit of time and computational power to get these trained, but then we can run all sorts of experiments. So we're looking at things like, well, if we had that same system under a 1 degree Celsius warmer climate, what would our stream flow look like? So this is one area of research. I also do a lot to look at how much and why extreme precipitation is changing. I won't go into too much detail here, but a lot of what we do is also, again, using data science methods or artificial intelligence to try to disentangle different drivers of extreme precipitation change. So if you look at this map of recent changes, you see some brown, so some decreases, some increases. What of this is natural variability? What of this is actually climate change? And can we sort of understand the underlying processes better so that we can make more definitive attribution statements and constrain some of our future changes in these types of events? All right. I have a little bit of time. Okay, so the other thing I wanted to talk about is then moving beyond more of this physical science research looking at some of the impacts of climate change. So one question I worked on is particularly trying to quantify the costs associated with precipitation change in the US, particularly related to flooding. So for this, we look at historical data, like 30 years of data on precipitation and flood damages. We have over 6,000 historical flood events that we analyze. And then we can combine this with an analysis of how the precipitation has been changing, some statistical models to understand how that affects the damage. And then we can come up with, I always forget, this doesn't always, anyways, how much of those damages were actually due to climate change or the changes in precipitation that we saw over this time period. So we find that actually a third of the damages we could attribute to changes in precipitation that have already been occurring. This is sort of the first like empirical statement that climate change is already increasing these costs at a national scale. And this method, again, where we have the data, we can extend this framework pretty easily. So we have a project where we looked using the exact same sort of method, how are increases in temperature affecting agricultural insurance claims in the US. So this is using historical data from the USDA insurance program. And we see that because it's been getting warmer, and that means that there are more drought and crop failures, and we get more losses as a result. There were 27 billion losses that we could attribute directly to increases in temperature over this almost 30-year period. And then I have a student, Nicole Keeney, who is a master's student in my group, and she's extending the work that I showed on the previous slide, linking changes in precipitation to flood damages. She's trying to work with global data for these types of events now, to see if we can make that connection and make those same sorts of statements linking quantifiable impacts to climate change. She's also looking at beyond just the like direct dollar damages. Can we look at the effects on fatalities or displacement or other sorts of metrics? So
1 minute.
1 minute, yeah, okay, cool. So I'm on my last slide. Yeah, so I just wanted to highlight my group. So I've only been here, I'm in my second year at CSU. So I have Mike and Nicole working with me, as well as some other graduate students who came in with their own funding. So Alexandria Rogers is co-advised with Antonio Miranetto in my department, and she's looking at levees and unofficial levees and how those modify flood risk. Bill Doan is a PhD student looking at climate change impacts on transboundary international water resources. And then we have some undergraduate research assistants working with us. So that's us. I'd be happy to chat more about anything that you're interested in.
Any questions from the room? I'll try and look on chat.
I know that was very fast.
That was perfect.
Yeah, Steve.
Thank you for that. And your prediction of non-stationarity, you kind of give the example of your 2021 article. Is that like post-analysis, or can you
Clarify which
you were just talking about like trying to determine whether it was affecting climate change or
for the changes in trends in extreme precipitation?
yeah,
Related to damages or just generally?
just generally.
Yeah, just generally. So, and your question is about the methods, or?
Well, yeah, I'm just we're always trying to predict whether this was a non-stationary event or whether this was just
A rare event.
a rare event or something like that. I'm just wondering if your research has helped to expose knowledge on determining future events to decide whether or not that's a non-stationary event.
So that's one thing that we're trying to figure out. It's really hard with just the historical record, because you could have 50, 100 years, and then you get a record-breaking event. Is it just because you didn't happen to observe that in the past 100 years, or is that actually an event that became more likely with climate change? And so there's different reasons climate change is making extreme precipitation more likely. The warmer atmosphere can hold more moisture, but also the actual frequency of these extreme events can change because of changes in the atmospheric circulation and weather patterns. So what we're using neural networks for is to disentangle those two things, because we have a little bit more theory on the warmer atmosphere, more moisture side. And then we can, so our evidence shows that both of those tend to play a role. The I'm trying to answer this in a very high level way, but the circulation changes in the climate, which have a big impact on where extreme events are occurring. So like part of why we've been in a long drought in the Western US has to do with ocean patterns and circulation. Those have a really strong natural variability component, but hopefully by isolating like that effect from a warmer atmosphere and some of these other things, we can identify where there's a statistically significant trend outside of natural variability. Yeah,
Cool.
that's not a very direct answer,
Oh.
but yeah, that's like the kind of stuff that we're trying to piece out so that we can have a bit more confidence or like more clearly link our different process understanding with the very noisy things that are happening in the real world.
Cool stuff, thank you.
Thank you, Francis. All right, next up, we've got Tammy Albrecht. And for folks online, just hold your questions until the end and we'll get to those, okay? All right, go ahead, Tammy.
Thanks, Karen. Thanks for also for organizing this. It's great to hear what everyone here is doing, other folks at CSU. Let's see. Yeah. Great. So I am in the Department of Ecosystem Science and Sustainability. I'm a human environment geographer, so I focus on water and environmental governance. And broadly speaking, my research really asks how governments and civil society actors shape resource allocation, access, and use. And the types of puzzles that I'm really interested in untangling have to do with institutions, cooperation, and responses to change. So I'm interested in the design and function of institutions for governance, which are the rules and norms and standards that shape water governance. I'm interested in understanding the conditions for cooperation on shared water resources and how our frameworks for governance respond to socio-environmental change and pressures like urbanization, climate fluctuations, and other regional or even global processes. And I apply these sorts of lines of inquiry at multiple scales. So at the international or transboundary water scale, I look at policies for water security and international agreements for water sharing. At the regional scale, I focus on cross-sector governance, and I look at some of the challenges of coordinating across sectors from land to water to energy to forests. And at the more local scale, I'm looking at water suppliers and how they make decisions in response to pressures and change. Some of the current projects in my research group span these areas. One is an interdisciplinary project looking at the governance of international wetlands. I have a student working on that. We're also looking at intersections between land and water use and development pressures in the Colorado River Basin. Another project looks at post-fire restoration and some wildfire impacts to water resources in Colorado. We have a team in the Department of Ecosystem Science and Sustainability working on that, along with a master's student and some colleagues here in other departments at CSU. And my final project is looking at water supplier adaptation, focusing on US water suppliers. And so I'll tell you a little bit more about a few of these projects, just briefly in the time that we have here. So in the US, water suppliers are confronted with both acute and gradually mounting changes that they have to respond to, whether that's having to do with natural disasters, supply chain disruptions, or changes in the workforce or aging infrastructure. And in response to these kind of mounting and quickly changing conditions, they have to make decisions that span kind of strategic planning and operational spheres in order to continue to provide high quality, safe and reliable services. And so when they're making these decisions, they can choose from a variety of actions, and their choices will affect their future resilience. There are some tools that are available to help them assess these different alternatives, but what leads utilities to make the decisions that they do from a social perspective isn't very well understood. And so in this work, we're using socio-technical systems framework. We're considering water utilities as this interlinked social and technical systems to meaningfully consider that interaction and how social and technical aspects are deeply intertwined. We're looking to understand both kind of how the institutions at the internal level of these water supply organizations and also externally influence their decision-making. And in some of this research, we found that due to kind of this complex and multifaceted organizational mission that water utilities have, they're constantly managing, trying to negotiate among competing rationales that guide their behavior as organizations. Oops. That's interesting. We also, so that's internally. In the external environment, we find that kind of there's a number of dependencies that they have on their institutional environment, which consists of the rules and governing structures from local to federal levels. And these dependencies influence what actions are able to consider, what the transaction costs are, and what actions are even feasible for them. We're also looking at post-fire restoration and impacts of wildfire on water resources in Colorado. And here we want to understand the performance of post-fire restoration projects from a social perspective, to kind of complement our understanding of the effectiveness of these projects from a physical watershed perspective. So we're looking at stakeholder perceptions of effectiveness and trying to understand how project benefits are distributed among and experienced by stakeholders. We're also looking at water and land use in the Colorado River Basin to understand how suppliers are responding to population and economic growth coupled with constrained water supplies. We want to understand the conditions that support sustainability transitions and the potential pathways that these changes might make. And so a connecting theme in all of this work is the importance of linking policy with interdisciplinary science, and how improved understandings of both the social and physical science underpinnings to complex socio-technical and socio-ecological systems can help us improve the design of policies and institutions for sustainable water governance. And I'm very interested in collaborating interdisciplinary to this regard. So thank you. I didn't even get the 1 minute warning.
Thanks, Tammy. Any questions for Tammy?
I was curious, you mentioned like some transboundary. I'm curious if you have any specific project. Yeah.
Me too.
Yeah, so I've like past work in a
Yeah.
number of different basins, so kind of comparative kind of analysis of basins from the Danube and Mekong, the Ganges, different places in the world. So some kind of comparative case studies in that way. But our current work is looking at international wetlands, and we're currently looking at a location in South Asia that might be cool as a study. Yeah.
Yeah. You showed Morelos Dam. Are you working on the Colorado River?
Yeah, the
Yeah.
picture. Yeah.
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 Spend a lot of time there. Okay. We'll connect about that later. Great, thank you, Tammy. Right, and next up we'll have Jacob.
Thank you, Karen. Thank you, everybody, for being here. My name is Jacob Peterson Perlman. I'm an assistant professor in the Department of Anthropology and Geography. And I'm going to focus my talk a little bit on groundwater. Just to introduce you a little bit about myself. I consider myself a human environment geographer. I focus on natural resources management, environmental policy, specifically within the context of water. And so within that, I focus on kind of two broad questions. The first being, how do political institutions and organizations adapt policies and practices to global environmental change? Secondly, which mechanisms and processes foster natural resources collaboration and cooperation, and then also mitigate conflict? And so within those questions, I have a few different areas of research that I happen to focus on. One would be on water conflict and cooperation. One of the specific areas that I've targeted in recent years, and I'm actually just about to start a new project through a grant with the Department of Defense, is the proliferation of dams in transboundary watersheds. And so in the past, I have compiled databases looking at dams that are either under construction, planned, or proposed in transboundary river basins across the world. And this grant is, at least in my part, is going to think about how to automate that search for these different projects using AI. So that's about to kick off. I'm also interested in water governance. In particular, a lot of my work has been focused on groundwater governance. This picture here is symbolizing the Transboundary Aquifer Assessment Program, which I happen to be involved with, which is binational collaboration between the United States and Mexico over 4 priority aquifers spanning the US and Mexico border. And primarily not just identifying characteristics of these aquifers, but opportunities for like assessing these in a joint manner. The third project that I've been working on in addition to this would be involving social capital, the role of social capital in post-disaster resilience and recovery. In particular, this is focused on Eastern North Carolina through an NSF grant, Coastlines and People. And through that, we're identifying how social capital can play a role in community level responses to these disasters of flood, water quality disasters, and storms associated with that. Within the rest of the time here, though, I'm going to focus more on groundwater. So I think I'm preaching to the choir here when people realize the importance of groundwater. It's the principal reserve of fresh water. It's a critical component of sustainable future water supply. When we look at this in terms of a United States context, groundwater, like surface water, is considered to be managed at the state level. And when I'm referring to governance, I'm talking about the making of laws, plans, and regulations. Within the American West, groundwater is becoming increasingly relied upon. The study of groundwater management and governance across the United States, but I'd say also already particularly in the West, has been neglected. We need to figure out better ways in which we manage this increasingly relied upon resource. So some of the questions that I'm hoping to answer involves how groundwater is managed and governed differently at the state level across the American West, how well groundwater management and governance practices align with physical groundwater processes. Can groundwater availability and use be monitored in ways that inform management practices? What are the gaps in data and information that would help improve management practices? And then finally, what are some general principles that can be used across the American West for governing and managing groundwater? So I'm taking the opportunity here to shamelessly plug a symposium that I'm helping to organize here on campus that is going to be taking place in less than a month's time here at the Laurie Student Center. We have 2 of our sponsors present here in this room, the Water Resources Archive and the Colorado Water Center. If you are interested, we are gathering academics, practitioners, stakeholders, farmers from across Colorado and Western states to come and be a part of this. Currently, I think we have 5 different states represented. And it's going to be an all-day symposium. There's opportunities for student involvement as well. We have a poster session that students can apply to, and I would certainly encourage you all to register by visiting the website, and also encouraging students to apply and get involved. This is part of a Warner College Dean's Approaches to Transboundary or Transdisciplinary Wicked Problems grant that I've been involved with. Some of the other things that we're doing would be creating a class focused on groundwater governance and management that we're hoping to have come online next year. We're also hoping to publish a journal article focusing on the results of the symposium and use the momentum generated from this symposium, hopefully to apply for some grants looking at this problem further, analyzing groundwater and governance management practices across different states. Just to give you an example, there's in terms of permitting, Colorado has a mandatory permitting regime where the state government creates and administers permit rules, whereas California has local agencies fulfilling the role of permitting. So that's just one of the examples of the great diversity that these states have, and we're hoping to delve into that a little bit as we have this symposium. So I think I'm exactly at 7 minutes, so I'm going to stop there and thank you for your time.
Quick question for Jacob. Do you, oh, go ahead. No, please.
Could you just let us know just briefly what you mean by conflict in your other projects?
Yeah, so when I look at conflict, it's mostly it mostly manifests through verbal disagreements, though there can be chances where the conflict turns a little bit more aggressive through either withholding water or destroying water infrastructure in some cases. When we're talking about in the context of dams, there tends to be a lot of conflict involving how the dam is going to be built, how the dam is going to be filled. And certainly this can be very, dams are seen as one of the key indicators of conflict in the Transboundary River Basin. Just to give you an example, when the Grand Ethiopian Renaissance Dam was being built in the Nile, the then leader of Egypt, Mohammed Morsi, said something to the effect of, "We will defend each drop of the Nile with our blood." Right? So very violent rhetoric, but what I often find is in the research is that while there might be really violent rhetoric like that, it very rarely erupts in violence. And I think at some level, states recognize that there's just a need to find some kind of cooperative framework. Is it always going to be fair? No. Is there still going to be conflict over how it's managed? Yes. But I think our job, or at least what I may humbly suggest as part of my job in research, is to try and find some of these solutions in which both state actors, non-state actors, local, regional actors as well can figure out some collaborative solutions.
Thank you, Jacob.
Thanks.
Right. And we are doing really great on time. So last up here, we have Steve. I know you all got scared into following the rules. Okay. Go ahead, Steve. Thanks for being here.
Great, thanks. Just to clarify, so I'm a professor in systems engineering. I do work with the civil and environmental engineering, but I just wanted to make sure other faculty member didn't think all of a sudden they have a new hire, or something like that. So my lab is a blue-green decisions lab at the Powerhouse. So my group does a lot of work with water energy nexus, sustainable community development, anything really sitting within that urban spectrum, using AI augmentation, decision analysis, and human behavioral modeling. But what I want to talk about today is a little bit is humans, right? So humans, that's sort of my premise, is humans are messy, but they matter, right? So I have a dual degree in psychology and engineering. So I kind of have always dealt with in both worlds of these philosophies, right? And so we think of like humans from this natural science, from this hard science world, we're like, oh, humans are messy, they're unpredictable, they're unconcerned with convenient symmetries that we like to apply within solutions and decision support, right? And they're just always around everything. And if you don't believe me, I have a couple of examples of like how we're just consistently providing inaccurate response to policymakers, right? So we're okay standing in long lines, but not short ones, right? Have you ever stood in a really long line at Disneyland, but got mad at the grocery store? Right? We'll pay 14,000 times the price of tap water if somebody gives us a bottle in admission with that. So if you look up how much it costs to fill a bottle of water, it's about 14,000 times. And then we do silly things like, we'll pay something that's more expensive. So we'll spend 15 minutes to save $7, but we won't, on a $20 pen, but won't travel 5 minutes to spend $20 on a $200 outfit, right? So we're constantly making these different things. And if you aren't convinced yet, these two orange circles are the same size. Right, so if you're looking at that, you're obviously crazy. Those are different sizes. What about this? Right? And then there, So they are the same size, but the way we see the world, the way we perceive the world is often, missed with those asymmetries, right? So what my lab tries to do is we sort of say, well, how do we use water within this complex realm of decision-making, growing pressures on resource constraints, climate change, and we sort of look in that particular world, right? And so the first thing, as engineers, we might say, well, we need to include humans. We recognize this. So I'm going to put a little parameter somewhere and say humans are going to do these things. But then how do we quantify that? Well, I think, presentation after presentation, I ask this question. It's terrible to put me in a presentation. I'm like, how'd you do that? So a lot of times we're sort of throwing a dart at a board. We're saying like, well, it's great that we included humans, but we don't actually know what they'll do. So we'll say, what if they do 20% here? What if they do 50%, right? So a lot of what my work does in my lab is trying to quantify that human behavior when we're presented with a number of policy questions, decisions, right? So just wanted to share a couple examples, do a lot with water and energy. So I'll share some from the water world. Like, so farmer actions during drought is a pretty complex environment, right? So farmers are constantly making decisions about water need, water availability, cost of water. Can I do something with my water? So we might go, well, what if we have a drought, right? And so we have normally this supply of water we typically have, and then now we have a drought, and so that supply is diminished. So then what's the plan for reducing all that water use? We'll put together a really complex, drought management plan, and then we'll push that out there, and then we'll forget to say, well, what will people actually do in these situations, right? So my research kind of looks at that. So we did some work in the Okanagan region of British Columbia, which is the Canadian desert. If you want to, think there's a desert in Canada, there's a small, tiny little one. We say, well, let's get farmers together and let's actually do this, do some drought scenario planning. Here's some data, so I can say, statistical analysis gave me, validation of what I'm going to say, right? But previously, drought plans were looking at options for, no water trading, no general allocation of, distribution of water, like all these different things, saying that farmers would not do this. So in our study, we kind of threw that upside down, and we said, you know what, farmers would be perfectly happy to trade water, as long as they're trading with themselves within their sector. Farmers would really prefer to have this moderate across the board drought reduction. A big push in British Columbia was to give water to the high value crops first, the things that you could sell in the market. This was exactly the opposite approach that farmers wanted. Anyway, so trying to do a thing. So it's kind of an example of like, if you try to quantify that directly, you might get completely different things. The residential side, right? We look at a watershed. We got all these little points of water use along the watershed, and we're like, we need to manage this watershed. So we'll kind of predict that. Well, how do we predict that water use? So some working with, landscape architects, looking at irrigation. We came up and said, oh, look, this is all the really cool ways we can do it. We can measure this, how much water you should do. These are all these cool things like that. But then the question of like, what directions should we do? If we're going to do a design guide, a design policy, what would that be? So we ran a couple scenarios. We said, well, what if we just put a policy that's your preferred lawn use and look at the adoption of that preferred lawn use? We could see versus this extreme water conserving variety, right? And these are across a couple different scenarios, but if you look sort of the extreme water conserving scenario on your right, or I guess, it would be your right, my left, versus preferred lawn scenario, policymakers might be immediately drawn to that preferred lawn scenario. They say like 83% of the population would like this more than an extreme conserving, so let's not even go with that. And so we say, well, let's push that a little bit further. Let's bring that data into a hydraulic model and forecast that over the years. And what we found is that extreme water conserving scenario, with fewer people adopting it, actually gives us the better results, better aspect there. So what we're trying to do is to say, really what we need are more localized policy solutions instead of these individual ones. So a lot of things my lab looks at are things around this localized policy area. So like public perceptions of reservoir operations, So how would hydroelectric companies operate their dams to connect with recreationists to do that? So we have a 10-year program with BC Hydro looking at that, bringing those things and adjusting water operations to try and maximize that aspects. Things like efficiency labeling for homes. You get buy your next house, you can have a little efficiency label on it and tell you what it is. We look at those, looking at willingness to pay for air quality, localized policy designs for heat transitions, and then bringing that all kind of to Colorado, since I came from the University of British Columbia in Canada, now here in Colorado in 21, we have a program looking at how do we take agricultural values and connect those with temporary water transfers so that all of that modeling comes together. So just a little bit of a highlight. Thank you very much.
Questions for Steve?
I'm curious that project about the perceptions about the reservoir operations. Can you just like briefly talk about the results that you got?
Oh, for sure. Real quickly, people who recreate on reservoirs do not like really high reservoirs that are completely full, that basically, you know, destroy the landscape, right? Use a big reservoir. And obviously they don't like really low ones. And so what we found is a kind of a preference range between that operational range, so that you would have more people recreating with the various different landscape amenities. And then so now BC Hydro tries to operate their dams, bringing water from the alpine reservoirs through the system so they can maintain this kind of sweet spot of a thing, versus a lot of times what they had done before is store a whole bunch of water and then release it during that economic value. And so you ended up with these, you know, dystopian empty reservoirs, which looks like, you know, we're water crisis or this, you know, flooded region, right? So now they try to be a little bit more balanced.
Great.
Thanks.
Any specific questions for Steve before we open it up to the whole group? And Steve, do you want to maybe sit over
Here,
so we
sure,
can
yeah.
have the owl focus over there, and maybe I'll move this. Okay, so a lot of great presentations there. I'd like to see anyone online have any questions to kick us off, and if not, we'll go back to the room. But I want to make sure you're all being heard on there. I don't see anything in the chat. You can just unmute yourself if you have a question. Okay. Questions in the room, and if you don't have any, I've got quite a few myself, so don't worry.
Are they for specific people?
They can be for specific people, they can be questions for the broader group, whatever you want to do.
I have questions. Okay, so Jacob, I was curious if you've been looking into the role of rainwater harvesting on groundwater recharge.
I have.
I was working with some folks in Arizona, who are really looking into that. My background is in rainwater harvesting, and so anyway, I was just curious if that was gonna be a part of it, but maybe something that we could talk more about later.
Sure, yeah, absolutely. I mean, certainly, I know it's a little bit different in Colorado, at least historically, right? But yeah, it could certainly play a role, and I'd be interested to hear what you've been done too, so, yeah.
So I think most of you, and maybe with the exception of Francis, but there's a lot of stakeholder engagement involved in your work. And I'm wondering, how do you approach that? How do you go about that? What makes successful partnerships in that realm, and why do you think that's important?
Yeah, I think stakeholder engaged research is critical for kind of answering the types of questions, at least that I'm interested in answering. Particularly because, you know, what we're trying to learn is how to, is information that should serve these populations, right? Should serve the stakeholders, should improve conditions for, in my case, for water utilities to be able to make decisions, for policies to be made that are targeted toward their needs and concerns and way of operating. So I think it's very critical to do the engagement, and I think that it does take time, right, to develop relationships and do stakeholder engagement in a way where the stakeholders are really benefiting from the research itself, and also having an opportunity to help shape and guide, you know, the questions that are asked and what's important and valued kind of in the research process itself.
Thank you.
I may build off of that. You know, I think in terms of having effective stakeholder engagement and collaboration, you know, the key word is trust, right? And so Tammy talks about relationship building, that's part of it. Something that's so hard to gain and so easy to lose. And I think the success of your stakeholder engagement process really hinges on that. And so what can you do in terms of building that trust? I think, yeah, ideally, if you can partner with stakeholders from the very get-go, build on those long-term relationships that you already have with certain stakeholder groups. But yeah, I mean, it's a very long, ongoing process. A lot of just simply showing up and listening, I think, is another key thing. I think as academics, it's one of our roles is as teachers to provide information and say that we're the experts. But oftentimes, if you're going to have success with stakeholders, you need to take a step back and you need to listen and you need to hear exactly what their concerns are, what they are saying, in order to actually achieve mutually beneficial situations for both the researchers and the stakeholders.
Thank you. Did you have anything you want to add, Steve?
Well, no, I think trust is very important. I think that's also a lot of what I do in my kind of stakeholder work is look for synergies, and shared ownership of the outcomes. I think that's, presenting and providing an opportunity for those that you're in the conversation with, that their, thoughts and perspectives could be somehow moved into that decision-making process is highly valuable. And definitely leadership, right? Or trust and listening is important. Reminds me of a story. The first time I talked with farmers as a young PhD, I used the word conservation, which was a devastating word to a farmer, right? That means loss of income, loss of livelihood, loss of, themselves, right? Whereas their perspective, the synergies were, how do we use the best resources available to us, right? So being able to listen and move the conversation in how they perceive, I think has been very successful.
Yeah, great point. Finding those shared values. You're talking about the same thing, but you need to make sure it resonates with them. Yeah.
I was gonna say too, that I think that, it's nice that we're doing this and having these conversations, and I think that the Water Center in particular could maybe, help connect stakeholders and practitioners to let people know what kind of research can be done or ways that, we can serve needs that are out there that we may not know about.
Yes.
And create that directional pathway.
Absolutely. Yeah, we're working on that.
Yeah, that's great. Looking
Actively,
forward.
yeah. And I want to bring in Francis, and I think, when we've heard all of your talks, there's like little threads that are similar among all of them. Did anything out of your listening to each other's presentations, something was like, oh, I should, follow up with this person, or like, what if we put together this joint thing? Or maybe Francis needs connection with some stakeholders and, those types of integration or collaboration activities.
Well, I kind of put Francis in the spot because I have a student who's trying to predict non-stationarity using machine learning.
Yeah, we should talk.
And so if you have the answer, that would be amazing. Because so far, everything you said resonated with the same challenge that we have in terms of water quality non-stationarity. So it's like, is this event because we just haven't ever seen it? Is this event because it is unique? And even when we have data that says something, like we have data from our fires and the watershed, and so we know that something happens, it's still challenging to even find methodological techniques that actually say that, right? Say and do that. So yeah, I'll definitely follow with you. That's challenges.
I was interested too, you're looking at some of the impacts of changes in snowpack on water availability, and like that's something that water suppliers have to respond to, and kind of how are they gonna make those decisions?
Yeah.
Yeah.
Cool. Yeah.
Yeah, I was thinking along the same lines. When I worked at the University of Florida Water Institute, I worked with essentially these climatologists and water utilities, and they were trying to get Florida as a crazy state for, climate models is like a pixel is, it doesn't predict Florida's climate very well. So they do all this downscaling and then they're trying to integrate better climate data into their water supply and demand forecasting. And I've had a few conversations with people about this, but I'm wondering like, you know, first of all, like what are people using right now? And I'm sure like the Denver waters are using, you know, highly complicated and great modeling, but maybe not, I don't know. And then like, is there a need for better integrating climate into their supply and demand forecasting? But, and then how do they actually make the decision? Because, that was another thing in Florida, it was like, you have all these models and things, but actually what it came down to was, you know, this person's been in this job for 20 years and they just kind of call the shots. And then that person retires and then the next person is like, wait a second, how do we make these decisions? So, yeah.
Yeah, those are the sort of things that we're looking at, kind of that organizational aspect of like decision making. You're right, you could have all this information, but what is the decision actually, you know, I mean, that's a component of the decision for sure, but there are other maybe constraints that they're dealing with.
Yeah, and I think like, some things that I think about related to this is like, in Colorado for water supply, people are often looking at like April 1st sweeps. So then all of the climate scientists are like, well, we need to know how April 1st snow water equivalent is going to change, but it's actually like a pretty bad predictor for a lot of places of how much water availability there is. So if we look at like, well, what are people actually using? Is it a good predictor? Is there a different predictor? And then how is that actually going to change in the future? I think even if my work is not like directly interfacing with stakeholders, there's a lot of ways that we could either ask additional questions or like reframe the questions that we're studying to be more applicable for whatever kind of decisions people are making. Yeah.
Absolutely. And I think that this kind of like this whole session is kind of like the intersection of kind of climate related information and data and how, you know, water practitioners and managers are using that information along with kind of these social institutional frameworks to make decisions. And Jacob, we had a panel on groundwater with Arizona, California, New Mexico, Colorado. I think that was it at the UPower conference this past September. And it was really interesting because we basically talked about that, and I'm sure the groundwater symposium is gonna bring that all together here at CSU too. But from your perspective, like what, I know you mentioned like data gaps and needs for that decision-making process. Are there key things that you think are lacking? Like what is missing out there?
Yeah, I think. I mean, there's just a lot of lack of information, period, I think, when we're looking at groundwater. You know, not just the hydrology of it, but also like, even if that water is usable. And, you know, is it of acceptable quality to be used? You know, yes, so there's a lot of need for monitoring, for data gathering. You know, we have, you know, some information on well levels, I think, that exists in most states, but you know, I think there's just a lot of information, and we're still, like, just to give you an example, you know, when looking at transboundary aquifers. So I'm also a member of the International Association of Hydrologists Transboundary Groundwater group, and you know, one of the things that one of the members does is put together a list of all the aquifers in the world, transboundary aquifers in the world. And 20 years ago, that number was around 300. 10 years ago, it was at 600. And then I think the most recent count is like 450, right? So just to give you an example of like, we don't really know what's going on down there. You know, like we have some idea. We know that there's some groundwater that exists, but does it connect with the surface? Or where does it connect with the surface? Or does it connect with other groundwater bodies? Like, these are the things that there's just so much to, I think, unpack and uncover. Before we can really, make effective decisions that are going to, influence how groundwater is managed. And, frankly, groundwater hasn't necessarily been focused on because it hasn't been relied upon nearly as much as it is being relied upon now. And so now's the time to really unpack some of these gaps in understanding and information that we have.
Yeah, I think there's kind of these different points in the decision-making process, and one is just like, you need the basic data.
And you need to share it. Like.
That's a whole other-
Right?
Gosh, yeah. And so these are like the common issues throughout these really complex water challenges. It's like, one, you need the data collection. And like, I can talk like South Platte Basin salinity issues. What's going on? Oh, there's some salinity issues in the South Platte. But what are the sources? What are the loads? What are the trends? And then, once you have that, some data, how is it shared? Is it available to everyone? Is it usable by people? And when you bring in the multiple, international and transboundary issues, that's when it gets really fun. Yeah. I was looking back, so Steve, you have, and I will pause too, because I'm totally dominating this whole thing. So if you guys have questions, please go for it as well. Yeah, go ahead.
So kind of returning back to the topic of stakeholder engaged research. It sounds like all of you are really interested in creating or doing research that informs good decision making. How do you get that information out to the folks who will be making decisions? Like what are your kind of best practices for getting them that information out to folks?
Yeah, and I'll just say similarly, there's a question on the chat of how do you get your work or message out to the general public?
Yes.
Good question.
I mean, I could start. I've sort of shortcutted that a little bit because most of the projects that I do, I formulate the project with the intended audience, just as sort of like, as opposed to that. But I mean, that's not always even that successful. And there's times where I've had stakeholders who argue with themselves about the results because one group is heavily involved and one group is not. Right. And then, or even part of government funded programs where I shared the results and then that just sort of disappeared into that. But usually what I try to do is just make sure it's always a stakeholder collaborative with the decision makers, because that shared vision, shared learning is so important. But that's I don't know if that's shortcutting the answer, because I don't know how to communicate it besides just having them involved.
I was just gonna say, I think it involves different lenses for different messages, certainly. I think one of the big problems that we as scientists have is just communicating to the general public. I think we're well housed in our own little towers of knowledge, and yeah, we can publish academic journals and stuff, but that's not going to necessarily reach the general public, and we need to do a better job of just speaking to regular people. Just also an idea, we can also hold symposia that focus on groundwater approaches in different states. And and I just sorry, I had to do one more shameless plug here for the event coming up in a month. But hopefully, the idea being that it's open to the public, we can have practitioners and people meeting with each other and like learning together and trying to learn from each other in different ways.
Yeah, I do think it is a constant challenge though, I think, and certainly always looking for ideas. And besides like sharing back to research, to stakeholders who participated in your research, like holding webinars, so like a symposium or holding a webinar that's public facing, trying to partner with, in the water sector, there are some great, national organizations that are really connected with utilities and other stakeholders. you know, they'd be great to partner with perhaps to kind of do something like that. Whether it's a webinar or like a public facing article. And then trying to, you know, publish not only the results in open access venues, but also trying to do articles that are more public facing, kind of op-ed type articles to distribute the research in a way that different audiences will see. But it's a great question. We should like have more discussions to try to come up with that, you know, more and better ideas.
Yeah, I do a decent amount of like media communication interviews, which just kind of like grew naturally out of I like did a couple of my PhD, and then people keep contacting you and it's like this giant flood happened. Can you do like an interview about why climate change is making this worse? And I actually think that that's made a huge difference in the past like 5 or 10 years in terms of the general public like perception of things like climate change and extreme weather. So it's like a very different type of stakeholder engagement, but I do think like, yeah, just general science communication to the public can be really effective.
I would also like to suggest that since we sit under the Office of Extension and Engagement, yeah, like, I mean, really having come from Extension, people need good information to give to communities. So I think more, yeah, and the Water Center, like helping to get that information out. An extension and engagement.
I would also say in multiple languages.
Yeah.
Because there's a huge gap in the information that's available in other languages around water specifically. And then students have been helping us because they know how to get information. Like they did all these cool videos. I don't even know what the heck would happen. Like Instagram takeover. I'm like, I don't know what that is, but that sounds amazing. You know, just like utilizing social media and really connecting in the students to the work and having them make recommendations on how we can get that done.
Yeah, and I think that's something for the Water Center to consider, like when we fund projects and stuff, how can we communicate the results out to our audiences? At least for those projects, and then like to the extent that we can support faculty that are doing awesome things in water as well. Have to communicate out. Other questions? And online questions. There is a question of where can I find the agenda for the groundwater symposium?
Hopefully later this week.
Okay, to be released later this week. Great. I was gonna, if there are no questions at this point, I was gonna ask Steve, it sounds like you work a lot with kind of the agricultural community around water. Is that true or somewhat true?
It is, we're just starting in Colorado, but
Okay.
like Canadian agriculture, but yeah, lots of time spending with producers and agricultural.
Yeah.
advice, yeah.
And you're just starting the project around kind of the values of the water sharing agreements? Okay, that's really interesting. Is that a CWCB project?
It is.
Okay, it sounds like something they would be interested in. Yeah, I mean, for Colorado water specifically, you know, the buy and dry of agricultural land and water is a serious issue at this moment in time. And so research that can help to address why, or methods to get around that, I guess, or to at least slow the buy and dry, because those water transfers have not been so popular for various reasons with agriculture. Tammy, are you doing anything in that realm with the Colorado River?
Some,
Okay.
yeah, I mean, as it relates to the buyers.
The dryers.
The dryers.
But I think one of the things we're trying to do with this small project, so Dixie Cote, which is one of my PhD students very interested in that concept, is inverting the decision-making process, right? And so often, you know, when we come from a science or a, you know, sort of a modeling perspective, we look at optimizing the decision from the criteria that's important from a kind of holistic science and ecology world, right? But then the decision makers have a completely different, you know, perspective of what they're trying to optimize. So water utilities trying to look at securing water for the next 50 years, you know, isn't necessarily looking at temporary water transfers because it doesn't fit within that decision-making structure, right? So then what is that decision-making structure that looks at how they secure water supplies, and then how do you formulate the trust and the, risk associated with temporary water transfers so that it fits within that water utility perspective or farmer perspective or something like that, right? So it's, because we can say, oh, hydraulically, it makes perfectly good sense. We'll just do this and we'll share there and we'll swap. And even like my research says, there's no grape growers in Colorado, but if they were, they'd be like, they want to share with anybody, the ranchers don't, like we can go through all that things, but ultimately it gets down to like somebody having to push that agreement or structure. So with, Dixie's project is trying to look at decision-making from the other direction and saying like, okay, this is what decisions are being made. What's the value and the trust and the collaborative structure that needs to be there in order to support those bigger outcomes?
Very cool. When's that project gonna be done?
So I think, well, so she's doing focus groups now, so
Okay,
yeah, so the summer will be kind of the first report out of there, and then
great,
a couple years after that. Answer reports.
amazing. Any other questions from our group? For this group? And I guess, I'm curious, like, do you all have more questions for each other, or are there other themes you want to explore with each other?
Question for Francis, just about your PhD student doing, transboundary,
Yeah.
Climate change, yeah, just the nature of that work.
Well, yeah, so this, as when you both mentioned that, I was like, oh, okay.
Yeah.
So I know nothing about that. The background is that Bill has worked for the Corps of Engineers on a lot of international projects, like in Pakistan and Afghanistan and Brazil. He's been stationed in all those places for a while. So yeah, he came back to CSU to do his PhD and is interested in exploring that idea. So I think he's looking at the Indus right now, since that's where he already has some models developed. But yeah, we might need some more expertise on the social side. Yeah.
Yeah, one thing that just came to mind too is like we, of course, as humans, to try and understand everything in little boxes, we separate out like the surface water and groundwater. And so, Jacob's talking about groundwater. I think you are mostly all talking about surface water. How can we like bring those conversations together a little more and talk about, because even in policy, they're so different. I mean, Colorado, you do have groundwater is brought into the prior appropriation framework, but I think we're the only state that really truly does that in the West. So I'm just wondering, like, how do we bring those together more, both in kind of the physical and then the institutional, and then like the policy discussions and research that we're having?
So,
Big question.
so interestingly, I'll share. So British Columbia, where I came from, the first groundwater law was put in place in 2014. So it just tells you how far behind British Columbia is in sort of understanding that. So there was no requirement to monitor, meter, report, or do anything with groundwater until the 2014 Water Sustainability Act, right? And so I can't say that, us Canadians up there have an answer, but one of the things we try to do in terms of the watershed planning is do climate stories. So it's British Columbia has first in time, first in right, just like Colorado, Western Law was all based on prior appropriation. British Columbia currently, basically owns the resources and in water leases. So you get a 40-year lease to your water, but you still run into those same conflicts, which is who gets the water first, right? And so we developed a number of climate stories to bring those impacts together between, the river and the groundwater and the farm downstream, and then to try to personalize it, right? I think there's interesting results with that. Like that's where we learned a little bit more about water trading. Farmers they don't really have a desire to put out the farmer downstream out of business, right? And so they're more interested in opening up conversations about water when they see those kind of impacts. But that's what we try.
That's cool. One thing I'm thinking is like, how do we, like forested headwaters and the way in which trees and plants are using water. And then, you know, with climate change and increasing temperature, how is that affecting specifically? I mean, I think there's work being done to look at surface water impacts, but what about like groundwater impacts and like aquifer recharge? Is that a big factor?
I think probably, and I don't think we're studying it enough as we should be. I don't know, like, your question, I thought of this of like rainwater harvesting and how does that affect recharge? It's like probably all of these things add up, but we don't really have a good sense of how much. So I think from like the physical hydrology side, they're definitely connected. Part of it, I think, is we don't have great data of the subsurface, so it's hard to study at scale. But then also like when there's more surface water, people don't necessarily need as much groundwater depending on where they are. So also like they're connected through the human management side. So I feel like particularly like in the context of climate change, I don't think you could really study them as totally independent systems. So it's mostly just agreeing with you that I think, yeah, they're having a more holistic or more communication between those communities is probably good.
I think it's challenging too, because like groundwater systems can be so local. And so like thinking about the Colorado River Basin, like we're talking so much about the surface flow and kind of allocating that. And there's so much less known about kind of groundwater resources in the basin and kind of at a basin-wide scale. And then it feels a lot of times they're so local in their extent. So how do we kind of integrate those conversations into at the scale of the basin as well?
Yeah, I was thinking more from my like data. Sure. Like, well, it's really easy to study surface water comparatively because there's so much like above ground observations and have more the subsurface, but like soil moisture, which would be like your connection between the two in terms of recharge, is a relatively new thing to be able to observe over large scales.
So I have a question to get thoughts on. Do water users in Colorado perceive themselves as one part of a joint system? You know, or do they see themselves in conflict of a resource? I'm just curious, like, where is the, like, what's the collaborative nature of different water users in Colorado?
That's complicated.
What's that?
That's complicated.
It's complicated. It's like water supply laws.
True
Yeah.
academic answer, it depends, right? Like, there's certain places where I think it's like, they're very aware of like the impacts that they have on their neighbors, like the Republican River, for instance, you know, they have downstream treaty obligations. There's 25,000 acres that are going to have to be retired in the next 4 years in order to fulfill those obligations. And so, you know, and I think also there's, you know, there's other recognitions, I mean, with the Colorado River and the treaty obligations to send water downstream. And I think there's a continuing growing recognition that, yeah, we're all have to figure this out together, and our use impacts others.
But I think there's a lot of regionalism, you know, urban, rural, west slope, east slope. Now we're getting down to northern Colorado metro. Like there's these divides happening as water resources, as growth continues to happen, especially along the Front Range. And how, you know, right now the policy is whoever has the most money can buy the water. And so, yeah, that is that. And then this gets into the social frame of, you know, what is equitable, what makes sense for our water use in Colorado. And I think we're really struggling right now to figure that out. And our institutions and political and legal frameworks might not support that. Which is why we have you all to answer all the questions and figure it all out. So. Okay, well, we are at time and I don't see any other questions online. So let's thank our wonderful speakers and for being the guinea pigs of the first session. So we will be back again March 31st. And thank you all online for joining us today. We're gonna have some treats and coffee over here, so have a good day. Right.